Welcome to Maths with Jade. In this video tutorial, we'll be looking at parallel and perpendicular lines. It's really important that you're already familiar with the equation of a straight line y equals mx plus c already. If you're not, I have a video on this and a link is in the description below. Now here's a little recap of that video. So we learned that y equals mx plus c is the equation of a straight line, and the m gives the gradient, which is how steep the line is. And to find m, we do the change in y over the change in x. C is simply the y-intercept, which is where the line cuts the y-axis. And once we have the value of m and the value of c, then we know the equation of that straight line. We also learn a formula to find the gradient if we have 2 points. And that is the second y point minus the first y point all over the second x point minus the first x point. And you need to learn this off by heart. It comes in really handy. And we looked at solving problems by either finding the equation of a line given the gradient and a point on that line, or finding the equation of a line given 2 points on that line. You need to make sure you're happy with all of that before you move on to the content of this video. So what are parallel lines then? Well, lines that never meet because they are always the same distance apart. So if I have this line and another line, I can say that these are parallel because there is an equal distance between them at all points. Here's another line that's parallel. Okay, so you might already know this. So let's have a little look if we plot parallel lines. Well, I have a line here and I have another line that's parallel to that line. Well, if we were to look at the gradient of the first line, then we get a gradient of change in y is 1, change in x is 1, 1 divided by 1 is 1. And then my other line, I have the same thing again. My gradient is my change in y, 1, over my change in x, 1, which means the gradient is 1 over 1, which is 1. Let's just look at another pair of parallel lines. So if we work out the gradient of one of them, our change in y is minus 1 because it goes down. My change in x is 2, which means my gradient is at negative 1/2. Well, if I look at my second line, which is parallel to the first, I have the same thing happening again. A negative 1 difference in the y-axis and a positive 2 difference in the x-axis, which means my gradient is negative 1/2. We can safely conclude that parallel lines have the same gradient from this. So if you were asked to find the equation of a line parallel to a given line, well, we can look at the line that we're given and say, well, we need to keep the gradient the same and just change the y-intercept. So a parallel line to this would be y equals x plus 1. The gradient is the same and the y-intercept has changed. Another example, y equals x minus 1, or y equals x minus 2. And we don't even need to plot it. I could go for y equals x minus 100,000, or I could even be really irritating and say y is equal to x plus pi, or pick another irrational number for the y-intercept, x plus root 2. All of these lines are in fact parallel because they all have the same gradient. Now let's look at finding the equation of a parallel line that goes through a specific point. So here's an example. We want to find the equation of a line parallel to y equals 2x plus 3, but it has to pass through 5, 9. Well, we know that y equals mx plus c, and we immediately know m because a parallel line has to have the same gradient as what it is parallel to. So we can replace m with the gradient. And y is equal to 2x plus c. Now we just have the problem of finding c, and we can use the coordinates we are given for that, just like you have seen in the previous video. We know that x is equal to 5 when y is 9, so we're going to use this. We're going to substitute in this given point. So we get 9 is equal to 2 times 5 plus c. Well, that's 9 is equal to 10 plus c, and then just solve to find c. I'm going to minus 10 from both sides to eliminate it from the side that has c on. And I'm left with c on its own, and c is equal to minus 1. There's my y-intercept. So I have the equation of my straight line. It's y equals 2x minus 1. Now for my second example, which is a bit harder. Now this is harder because the line that I'm given is not in the form y equals mx plus c, so I can't determine the gradient yet. So my first step is I am going to rearrange the equation that I am given into the form y equals mx plus c. So here's the line I'm given. I'm going to minus 4 from both sides, and I get 2y equals minus 10x minus 4. And because I want y equals and not 2y equals, I'm going to divide every term by 2. And I get y is equal to minus 5x minus 2. And if I just write y equals mx plus c underneath this, then we can quickly determine the value of m. So I'm going to replace m with that gradient of minus 5 because I am finding a parallel line to that. But we can't state just any parallel line to the given line. We need one that specifically goes through the point 3, minus 3. So we know x is 3 when y is minus 3. So I'm going to use this to find our specific value of c. When I substitute in those coordinates, I get minus 3 is equal to minus 15 plus c, and now I just need to solve. So I'm going to plus 15 to both sides, and I'm left with 12 is equal to c. And so I have found the equation of my straight line that's parallel to our given line and passes through 3 minus 3, and it is y is equal to minus 5x plus 12. Time for you to have a go at this. So find the equation of the following lines. Pause the video now. Here are your solutions. Please check your answers carefully. Well, that's enough of parallel lines for now. What are perpendicular lines? Well, they are lines that intersect at right angles. For example, this green line and this purple line are perpendicular because they intersect at a right angle. So does that blue and yellow line. But let's have a look what happens when we plot perpendicular lines on a graph. Well, let's find the gradient of that purple line, and I have a change in y of 2 and a change in x of 1. So my gradient is 2 over 1, which is 2. I'm going to call that m1. My second gradient, I have a change in y of minus 1 and a change in x of 2, making my second gradient minus 1 over 2. Let's look at another one because the pattern isn't quite so obvious. So I have two lines that are perpendicular. The gradient of one of those lines is 1 over 3, giving me 1/3. And the gradient of my second line is minus 3 over 1, which is just minus 3. So you should see that the gradients of two perpendicular lines have a product of minus 1. Okay, so I realise that isn't too obvious. But let's have a look at our first gradients of our two perpendicular lines and multiply them together. Well, 2 times minus 1/2 is equal to minus 1. And let's do the same thing with our other pair of perpendicular lines. I have 1/3 times minus 3, and I get minus 1. So if I have two perpendicular gradients, they will always multiply together to make minus 1. So right now I'm drawing you up a table, and it's got two columns, M1 and M2. M1 is the gradient of a line. And in the M2 column, I would like you to write the gradient of a line perpendicular to that specific M1. Really, all you need to do is find the number that multiplies with M1 to make minus 1. For example, the perpendicular gradient to a gradient of 8 would be minus 1/8. Pause the video now. So here are your solutions. Essentially, all we are doing to find our second gradient, M2, is doing the negative of 1 over our first gradient, M1. And this is called the negative reciprocal. It's important you remember this term because I'll be using it again. Now let's look at finding the equation of perpendicular lines. So for example 1, I want to find the equation of a line perpendicular to this given line and that passes through the coordinates 3 minus 5. Well, I know that my gradient of this given line is 1/2, So to find my perpendicular gradient, I need to find the negative reciprocal. So my second gradient of the perpendicular line will be -2. So if we have y equals mx plus c, I now need to replace m with the gradient. So m becomes -2, so I get y is equal to -2x plus c. And you should be so familiar with what to do next, because we know x is 3 when y is -5, so I'm going to use this to find c. So I'm going to substitute in the coordinates of the given point, and that gives me -5 is equal to -6 plus c. Now solve to find c, plus 6 to both sides, and I get c is equal to 1. Well, if I know my gradient is -2 and that c is 1, then I know the equation of my perpendicular line is y equals -2x plus 1. And there you have it. One more example then, and this one's going to be a very tricky one. So I need to find the equation of a line perpendicular to this horrible looking line and that passes through the coordinates 6, 1. Well, the problem with this line is we don't know by looking at it the gradient. So I need to rearrange it to put it into the form y equals mx plus c. So I want y on its own on one side, so I'm going to plus 2x to both sides. And that leaves me with 3y on its own. So to make it just y, I'm going to divide every single term by 3. And I am left with y is equal to 2 over 3x plus 6. So that means the gradient of the line I'm given is 2 over 3. And if I find the negative reciprocal of that, I will find the gradient of my perpendicular line. So m2 is equal to -3 over 2. I've just flipped the fraction and changed the sign. Now I'm going to replace m with that gradient that I've just found. I get y is equal to -3 over 2x plus c. It should be getting very repetitive now, so we're going to use our coordinates to find c, because we know when x is 6, when y is 1. So I'm going to substitute in the coordinates of that given point, and I get this. Now it's a bit ugly, so we're going to simplify it immediately. -3/2 of 6 is -9. We're basically dividing by 2 and then timesing by 3. Now we will solve to find c, plus 9 to both sides, and 10 is equal to c. Lovely. So if I know my y-intercept and I've found my m already, then I know the equation of my perpendicular line. So now it's time for you to have a go. Find the equation of the following lines. Pause the video now. Here are your solutions. Please check your answers carefully and try to go back and see where you went wrong if you went wrong. Thank you for watching. This has been Maths with Jade. And you've made it to the end of parallel and perpendicular lines. If you found this video useful, please hit the like button. Subscribe to my channel so you don't miss out on content. Share this video and all comments are welcome. See you next time.